This is Algebra 1, Semester 1. It's a unit called Systems. It's the 4th unit. And it's the 3rd lesson, Solving Equations by Graphing Practice. It's on creatormath.com under the Algebra 1 tab. You might have to type in creatormath.weebly.com into Google to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So before we do the problems, let's go find the notes. That can be difficult for students. I try to show it every time. Let's get out of Desmos. Let's go to the website. So here's the actual website name, creatormath.weebly.com. If you Google that, hopefully you can make it to this homepage. If you're having any questions in your mind about what to do about the comp book, then please just scroll down on the website to where it says composition book, right? I can read it to you, or you could just read it yourself. I've talked about it a lot, but it's here for your posterity's sake to go back and see what do I need to do on the comp book. Follow all the directions, watch all the videos, adhere to the turn-in dates, put everything where it belongs, and don't forget the notes, right, which are under the tab of the class we're in, or in this case, the video we're making. Right, this tab, each tab has 4 things under it. The actual notes, what pages they go on, the problem sets, which we're going to do one here, the actual videos we're making, and of course the vocabulary. So the vocabulary, if you're not getting 100% on your vocabulary practices, then maybe you don't realize there's a complete PDF of all the vocabulary words for the entire school year, and it is downloadable to your device, and it is searchable. Just Google how do I search a PDF with whatever type of device you're using. The instructions are a little bit different for each type of device. Next most important thing is to make sure you're in the right semester. Usually if you're looking at this, it's going to be the semester you're in. For us, it's the semester of the video we're making right now. So under each semester, you'll find the table of contents for that semester. This is very important, so important that I ask students to write in the 3.5 pages of the table of contents into pages 2 through 6 of their composition book. That way they don't have to guess or go back to the website at any time. They can just tell from that table of contents on which page all the notes go and are. So if they need to look anything up, they just go to that table of contents. Next, we're going to find the unit we're in. So we're in the 4th unit here called Systems. Then we're going to find the lesson we're in. This particular lesson we're working on right now is lesson number 3, Solving Equations by Graphing. Here are the page numbers that the notes go on in your comp book. That's why you number all pages, and you follow that video to do so back on the home page. We're going to open up notes in a second. This is the problem set we're doing right now, and the video solutions will be linked here if everything works right. All right, so we're going to click Notes. It does take me a couple times to open this sometimes, you guys, so don't be alarmed. This one happened to open on the first time, and you're going to write these notes into your comp book. They're not that elaborate and they're not that long, but it's simple things like given an equation y equals 1/2 x minus 4 and y equals negative x plus 5. Graph both lines, all right, if I can talk. So this one's interesting. Look at how we graphed it, right? We did a little bit sloppy here. So it says can't tell intersection from rough graph. And you're welcome to use the grid paper in your comp book, but maybe you got a comp book without that. Maybe it's just lined. Mine is. I let you guys choose what you want to do. I can make my own grids pretty easily, and I encourage students to do what works for them. All right? So I can't tell the intersection. I graphed this a little too sloppily. But notice down here, I mapped it out a little cleaner, and you'll see the way I graph too. You can graph it like this, just loose freehand, I call it, graphing by hand. These, you're not going to get any decimal results from these equations given here. You're going to get pretty straightforward results. And so we can see right here, 1, 2, 3, 4, 5, 6, -1. That's the location of this intersection or the solution to this system of 2 equations. All right, a system is just 2 equations or 2 graphs on the same graph. Put these other things in here like what's a solution, what y equals mx plus b is, and what m and b are, which you should know by now, but it's good to review that, so make sure these notes are in your comp book. With that, let's look at the problem set we got. What is a system of equations? So the system is 2 equations on the same graph. If you got a graph, you got x and y axes, right? And say you got a graph and a graph. And the solution to this, what is the solution to a system of equations? That is the point of intersection of the 2 graphs, where the 2 equations cross or intersect. And maybe it should say where the graph of the 2 equations cross or intersect. That is, they have the same solution. In other words, if you plug in the x value and the y value of this place, it'll work for both equations that were given. Okay, and we'll show that too here a couple times. So let's go straight to sketching by hand, and let's go ahead and look at our two first equations. Use hand sketching graphs. Use hand sketched graphs. Using hand sketched graphs, what is the solution to the two equations, y equals x plus 1 and y equals minus 2x plus 4? So let's give ourselves a grid. It's not real perfect, but I see here I'm going to start with what the y-intercept. That's how we graph. It's plus 1 on this one, so here's a plus 1. And the slope here is 1 over 1, rise over run, so 1 over 1, put another dot here, and let's make a line through like this. That's our first one. Let's look at this one here. It's plus 4, and we're going kind of quick because we had a whole unit on how to graph the y equals mx plus b, the slope-intercept form of the equation of a line. So we're assuming you've been through those lessons, and we're building on that. We're not going to take too much time to go back through. So I look for plus 4. 1, 2, 3, 4. Notice my units are equally spaced if I can, but obviously they're not perfect, right? Here's 4. And so the slope here is negative 2. Remember, negative 2 is negative 2 over 1. So we rise, or in this case, go down 2 and over 1. So go down 1, 2, and over 1. Look at that. I can tell where we're crossing through right there. Both lines go through this 1, 1, 2. 1, comma 2 is the location of this solution. 1, 2. All right? And just to the idea of why it's called a solution is, look. Take y equals x plus 1. We said x was 1, so plug in a 1 here. And we said y is 2 right here, right? Does 2 equal 2? Check. So that's what we call as this one fits. Now look at this one too. The x is, let's rewrite it, y equals negative 2x plus 4. Can I still see it? There we go, just barely. All right. Y equals negative 2x plus 4, right? Let's start over a little bit. Go back here and put the x of 1 in. So there's a 1. It's times negative 2, and it's plus 4 equals, and the y we said was 2. Right? Negative 2 times 1 is negative 2 plus 4 equals 2. And kind of you have a, a circle here. We don't know this for sure, but look, 4 minus 2 is 2. 2 equals 2. Check. So at this location, this 1, 2, why this is called this solution here is because this value works for both, and that's the thing that we like so much as math teachers. We're looking at these two graphs intersecting at this point. All right, use hand sketch graphs. Let's do another one. We've got 2 left, and then we're done. So let's draw this. Let's go to a negative 1. Let's go 4 over 1. So put a dot. 1, 2, 3, 4, and over 1. Okay, that's this line. Then we go to plus 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. That caught me off guard. I'm all the way up in the other problem. This is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's way up there. And I would have liked to have drawn my graph lower, so I'm sorry about that. In fact, there, look at that, that's how high it is right there. I'm up in the other one. Okay, so let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's this 9. And now we're going down 1 over 1 because it's negative x. So there's a negative 1 there, which equals a negative 1 over 1 for the slope. Right? That's right here. Right here. And it's a negative 1. So negative 1 over 1. Down 1 over 1. So start way up here at 9, go down 1 over 1. Right here. Okay, because we're going straight down here. This one's going to be a little bit hard for me. I'm not sure I can see this one really clearly here. So, where am I? I'm tempted to say I'm at 2. 1, 2, 3. Wait, sorry. Sorry, guys. Let's reorient here. Let me go back. I'm trying to see if I can make it. There's my intersection, right? It looks like I'm 2 out on the x. And if I count 1, 2, 3, 4, 5, 6, 7, looks like right here on the y. So, not perfect, you guys, but I think I'm 2, 7 here. For right here for the intersection. So sure enough, and look what they've done in the answers. First of all, is it 1, 2? Is it way down here for the intersection? No. Is it negative 1, 2, negative 7? No, it's not even over there. So they haven't made it so close that we can't just figure out the answer from the answer choices were given to us, okay? So we don't really have to graph that perfectly to go, oh yeah, it's 2, 7 in this case, all right? But it gives us practice in hand sketching, and it's kind of fun. All right, let's do the next one. -3, 1, 2, 3, and let's go up 2, so put a dot, a point. Up 2 over 1, up 1, 2 over 1, put one here. Draw as straight as we can. I'm not even using a ruler, but my lines are pretty straight. -9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Way down here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then down 1 over 1. So if this is here, right, this is coming here, down 1 over 1. Okay, so this is going to connect. I need to turn the paper to draw a straighter line, you guys. Something here. All right, now let's see if I can figure out from this. Where am I? Right, so I'm definitely negative. Let's see. Say this is here and here and here, and I don't totally know if my grid is the same here, but this looks like it could be here, right? That's parallel to this. So my x, I'm going to say, is -2, and 1, 2, 3, 4, 5, 6, 7. I'd say 7 is my closest. It could be 8, but it looks like 7 there. So -2, -7. And sure enough, there's no other answer choice that's even close to this. 1, 2 is not even in the same area. That'd be over here. 2, 7 would be way over here. Nope. So they're making it so my graph, you know, I don't have to be perfect on my drawing. I can still get the right answer here. All right. So that's using hand sketching to find the solution to a system of equations where a system is just 2 or more graphs on the same, 2 or more lines or equations graphed on the same graph. So make sure you're matching up the title of this video, Algebra 1, Semester 1. It's the 4th unit, Systems, and the 3rd lesson, Solving Equations by Graphing Practice. It's on creatormath.com under the Algebra 1 tab. Hope this helps.